I'm going to go through in this video some of the book problems that you are doing for volumes for disk method. I've already done all of the problems out here, so I'm just going to walk through the work that I did. In some cases, I used Math 9 on the calculator. I integrated, and I'll talk through how I did that. So the first one here, I have this y equals 1 minus x. I'm revolving it about the x-axis. That tells me it's dx because of this rectangle, and anytime I go about the x-axis, it's dx. Volume is this formula, r squared dx with that pi, and that radius is this length right here. So it's 1 minus x. My bounds are from here, this 0 on the x's, out to that 1 on the x's. So then I plug that stuff in. I get pi integral 0 to 1, or 1 minus x squared. And this is one where I used Math 9 on my calculator. I typed this part in to the calculator. I left the pi off. And then it gives you something that you can math frac if you'd like. For that one, I got 1/3 when I did my Math 9. So I just then multiplied the pi by the 1/3. And so I got pi over 3. I have an exact answer here and a decimal answer here, rounded to 3 decimals. Let's go down to number 2. This one was pretty similar. Again, it was revolved about the x-axis, so it's dx. I have y equals 4 minus x squared as my function. That radius is this height, so the r of x is 4 minus x squared. And my bounds in this one go from 0 to 2. Why is that? Because the starting x value of this region is 0, and the ending x value is 2. So those are my bounds. Pi, when I plug all this stuff here into the formula right there, I get pi integral 0 to 2, 4 minus x squared squared. Don't forget that second squared, dx. Once again, this is one I'm going to Math 9 on my calculator. It's doable by hand, but it's a lot of arithmetic. So I Math 9 it. I get 256 over 15 when I Math 9 this stuff. So it's that times pi, that guy. And then when I multiply out and round to 3 decimals, I get 53.617. Next one here, we are just taking this red spot of y. Man, come on, the mouse is losing its mind. Take this red spot right here of root x, and I'm revolving it about the x-axis. Again, revolve about the x-axis, it's dx. So my volume formula, pi integral r of x squared dx. In this case, the radius of that shape is root x. So r of x root x. My bounds in this one are a little bit different from before. Notice here I'm only doing this red region, so I start at x equals 1 and go to x equals 4. So I do pi integral 1 to 4 of root x squared dx. And this was one where I was like, you know what, I'm not even going to take the time to Math 9 it because it's faster to do it by hand. Because when I square that, I just get x, simple power rule, evaluated from 1 to 4. So I get this pi over 2 out front. 4 squared minus 1 squared gives me 15. So I get 15 pi over 2, which is to 3 decimals, 23.562. So this next one, number 7, is the first one for which I'm revolving it about the y-axis. When I revolve about the y-axis, I'm going to do dy. Man. So this shape would be like that. So I do pi times the integral, and this is where it's different from the ones above. So r of x, I have r of y dy. My y's start at this 0 and then go up to the 2. So that gives me my bounds from 0 to 4. And then they tell me in the problem that the equation is y equals x squared. But remember, when I do dy, I need to solve for that x. So I take this thing and I solve for x. I get x equals root y. So that root y is my r of y. Come down here, plug all those pieces in. Pi bounds from 0 to 4, root y squared dy. And again, this is one for which I'm not going to waste my time with a Math 9 because it's really easy to do this integration by hand. Pi integral 0 to 4 y dy, power rule y squared over 2 with the pi. And then it evaluates real simply because the 0 bound just gives me 0. I get 16 times pi over 2, which is 8 pi, which rounds to 3 decimals, 25.133. Next one, this one is, it's actually a semicircle. I've got y equals root 16 minus x squared. We're revolving it around the y-axis, so this thing would look like a dome, sort of, like a half dome. When I revolve about the y-axis, it's dy. So I use pi integral r of y squared dy. And then just like in this one up here where I solve for x, I need to take this equation here and solve for x. So it's currently in that y form. I square both sides. I flip-flop the x and the y, so the x squared and the y squared there. And then I square root. And I get x equals root 16 minus y. So that becomes my r of y, gets plugged in there, and my bounds go from 0 to 4. So with this one, I did use Math 9, but I simplified it before doing the Math 9 because it's easier to type in this other form. So I took all those pieces, my bounds 0 to 4, my r, that root, but look, it's squared. So the root and the square cancel with each other. So it just gives me 16 minus y squared. And then that's easier to Math 9. You could totally do it from this, but you might mess up some parentheses or something like that. So I Math 9 that. I get 128 pi over 3. Remember, I am Math 9ing, oops, not that. I'm Math 9ing this. I am not including the pi in my Math 9. And then I do a math bracket, right? So and that gives me 128 over 3. Tack the pi on, have an exact answer, and then get a 3 decimal answer by multiplying the 2 on my calculator. Number 9, they gave me y equals x to the 2/3. They were revolving it around the y-axis again, so again it's dy. And then, so I use this formula just like we used for the last two. Again, I have a y equals form, so I need to solve for x. X is y to the 3/2. So that becomes my r or y. And then my bounds, my low y is here, my high y is here, so I'm going from 0 to 1. So I got all that stuff. I plug it into this formula, pi, integral from 0 to 1, y to the 3/2 squared dy. I guess you could Math 9 it, but I looked at this and I was like, oh, the square cancels with the with the half power there, and gives me y cubed. And then again, for me, it's just, and I think for you too, potentially, it's just faster to do this integration by hand than it is to type it into the calculator. Integral 0 to 1 of y cubed dy is 1/4 y to the 4th with that pi from here. And then when I evaluate it from 0 to 1, I just get 1 to the 4th, which is 1 minus 0. So my answer is pi over 4 to 3 decimals, 0.785. Last one here. I've got this shape, and they actually, look, they gave this one to me in a x equals form, which is convenient. It gives me less work to do. We revolve it about the y-axis again, so dy, so the same formula as previously. And then, you know, I've already solved for x, right? So, or they've already solved for x for me. So, my r is this, which is just that formula. And my bounds is a little bit different here. See, we start at 1 and we go up to 4. We're not including this part of that parabola down here, so we just do our bounds from 1 to 4. So I get pi integral 1 to 4. The r is this squared dy. And this is one that for sure I want to use Math 9. I don't want to do all that work. So I Math 9 that without the pi. I get 153 over 5. Put the pi on there. and then get the 3 decimals, and I get 96.133. So hopefully that helps clear up any questions that you had about any of these. And I will see you soon. Peace.